Welcome to Section 5, Adding Probabilities. One thing I want to keep in mind, and I want to constantly reinforce this, because when it comes to adding probabilities, and when it comes to multiplying probabilities, and when it comes to ultimately finding any probability, anytime you're finding the probability of an outcome, it's going to be the number of ways that the outcome can occur on top, and then on bottom of the fraction, it's your total outcomes. Okay, this is something that as long as you think about this, and as long as you focus in on this key idea, the most basic idea of probability, then you're going to be headed in the right direction, and you don't have to memorize quite as many rules when it comes to, do I add these probabilities, do I multiply them, what do I do with them? Okay, this will be your guide for everything that you do. The first special case that we're going to talk about is mutually exclusive. So mutually exclusive means a series of events that cannot happen at the exact same time. So if you look down here, this kind of gives you a preview of where we're going with this. The probability of drawing a 2 or an ace. So for instance, when you draw, you're going to get one or the other. There's no case where you're going to draw something and it's going to be a 2 and an ace. You're going to see this in future events, where events that are not mutually exclusive, such as drawing a 2 and a heart, or something like that, where there is a 2 of hearts where they can occur at the same time. We're going to talk about that section next, but right now we're focusing on things that cannot happen at the same time. So a 2 and an ace are mutually exclusive. They simply cannot be happening. You cannot draw both of them at the same time. If you determine that 2 events are mutually exclusive, they cannot happen at the same time, then the probability of finding them, you simply add the 2 probabilities together. Mutually exclusive, here's another way to look at it with the Venn diagram, and you're going to see this again later on when we talk about the case where events can happen at the same time. But basically, this is event A, this is event B. There's no overlap. There's no instances where they occur at the same time. So we simply add the 2 probabilities together to get if it was A or B. And you could extend this to C. It could be A or B or C, and then you just add the probability of C on the end. Okay, so looking at the probability of drawing a 2 or an ace from a standard deck of cards, what I would consider is, again, going back to our first slide, where the probability is the number of ways the desired outcome can occur, so those are successes, over your total outcomes. So here, maybe instead of trying to memorize, hey, I'm going to add these probabilities together, I'm going to keep that basic idea in mind and say, how many times can a 2 or an ace occur? There are 4 2s. There are 4 aces. That means you can draw a total of 8 things and get a 2 or an ace, and then your total is 52 out of 52 cards. Okay, so as long as we keep that basic idea in mind, that's really the driving force behind finding the probability. So we can take this, we can write it as a decimal if you'd like. I'm just going to leave it like this for right now. We can reduce it, make it 4 over 26, and then 2 over 13 would probably be the more appropriate answer, just because it's a reduced fraction. Okay, and that's found right down here. Also, another way you can do this is you can say the probability of finding a 2, which would be 4 out of 52, right? And then we add that to 4 over 52, which is the probability of finding the ace. Then we would, again, add these, and we'd get 8 over 52, and again, we get the same answer. And I think that this comes where the thinking portion comes from it, and the understanding that to find the probability of a success of the desired outcome, you have to see how many total possibilities there are over your sample space. All right, for the next example, you're given a situation, and you're finding the probability of randomly choosing a heart or a club. So probability of heart or club. And knowing that these are mutually exclusive, we can say this is the probability of drawing a heart from here, plus the probability of drawing a club from here. Also, another way to look at this is, if you're talking about a heart or a club, how many hearts are there? There's 10 hearts. There's 7 clubs, so that means that there's 17 possibilities out of your total of 25. So you could say that the probability of drawing a heart or a club would be 17 over 25. Or you could say the probability of drawing a heart would be 10 over 25 plus the probability of drawing a club, which would be 7 over 25. And again, you're getting the same answer either way. And either way works for you. Go for it. All right, the next example, a die is rolled, a single die, it's six-sided. So the possibilities are 1 through 6. So when looking at this, we want to see which conditions satisfy this. So the probability of drawing a 1 or a 6, there's two possibilities out of a total of 6, which would be a probability of 1/3. Another way you could do this is you could do the probability of 1 plus the probability of a 6, and again, you would get the same answer. The probability of drawing at least 5. So at least 5, I like to draw this line right here and say, here is the section I'm looking for the probability of. So that means that I have two possibilities. It could be 5 or 6 out of 6. And again, this is 1/3 probability. For the next example, probability of finding one less than 3. So 3 cannot be included. But what you can do is you can do, and I would strongly encourage you drawing this to look at and see what possibilities will fulfill it. Here there's two numbers that will fulfill it, 1 and 2, out of your sample space, which is 6 possibilities. And again, that is 1/3. Probability of it being even or prime. Looking at my set of numbers, my even numbers, 2, 4, 6. My prime numbers would be 3 and 5. 1 is not considered prime. So here we have 5 possibilities that make it a success, make it what we're looking for, out of a total of 6. And again, if we were only to write any of these as decimals, I wouldn't be mad about it at all. Decimals or fractions should be the way that we write probability. All right, the next one, probability of multiples of 3 or 4. How many numbers will make this true? 3 is a multiple of 3, 6 is a multiple of 3, 4 is a multiple of 4, so that means that we have 3 possibilities that will fulfill it out of the 6, which gives us a 1/2 or 0.5 probability. And the last one, the probability of finding something that's a multiple of 2 or 3. Here's one that's a multiple of 2, multiple of 2, multiple of 2. And then here's a multiple of 3. That means that 4 outcomes will give us our desired. Okay, and then that's a total of 6. So that would be probability of 2/3 or 0.6 repeating. So again, on these, you can add the probabilities. There's absolutely nothing wrong with finding the probability that's a multiple of 2 and then finding probability that's a multiple of 3 and adding these two together. However, I think that it's more valuable that you can think through it and that you can use a little diagram sketch to help you see what conditions will make it a success and which conditions will not. Okay, all right, the next one is looking at different movies. 9 comedies, 5 action. I like writing this out to the side just to see the information a little bit more clearly. They plan on selecting 4 films at random. So here's the 3 different scenarios that can happen. Okay, each of these are mutually exclusive. Okay, so these will not be able to occur at the same time. So what we can do is we can add the probabilities. So we want to, again, look at our sample space and our successes. So here's going to be the first one, 2 comedies and 2 action. If we look at this, our total ways that this can be fulfilled is going to be, first for comedies, we have 2 comedies out of 9. So we have 9, choose 2. And then for the other ones, we have 2 action movies. The way we can choose 2 action movies from the 5 would be a combination of 5, choose 2. And then over the entire sample space, which is going to be 14, and we are choosing 4. So this represents all the possible ways that we can choose 4 movies from the entire 14. And this is actually going to be the sample space for all of these scenarios because we're always choosing 4 from 14. Okay, for the second condition, we have 3 comedies and 1 action movie. So we have 3 comedies out of 9. So we have 9 choose 3. And then we have 1 action movie out of the 5. So we have combination 5 choose 1. And then our final one, we have 4 comedies, no action movies. So 4 comedies out of the 9. So 9 choosing 4. And we're multiplying that by the ways that we can choose 0 action movies. So combination 5, we're choosing 0 of them. Okay, and now we have to find these probabilities and add them together. So notice these are all combinations because order is not important. And another thing to consider is that we have to choose 4. So here we chose 2. Here we chose 2, so that's a total of 4. Here we chose 3 and 1, so that's a total of 4 movies. So again, we're finding the total possibilities that would make it true, and then we're finding the sample space, or using the sample space rather, with the total number of outcomes. So doing some simple math here, doing this all on your calculator, I find the probability of this to be 906 over 1001. And the way I did that is I found this first probability, I wrote it down, I found the second probability, I wrote it down, I found the third one, and then I added the 3 together. So those would be your steps to follow. Okay. Inclusive events are it's the opposite of mutually exclusive. So mutually exclusive meant that 2 events could not happen at the same time. Inclusive means they can happen at the same time. These would be 2 events like choosing a king or a spade. So there's a king of spades, so these 2 can actually happen at the exact same time. That's where this piece of the Venn diagram is represented. So this would be probability of A, this would be probability of B. Here's the overlap of where they both occur. So what happens here with an inclusive event, things that can happen, is we find the probability of inclusive events by adding the 2 probabilities together, so adding these circles together, and then we have to subtract this middle because when we add A and B, we're actually counting this middle twice. So we want to subtract it out so that we're only counting it once. And I'm going to give you a few different strategies to use on these, and I think that some of these might be more helpful than others. So the first example, if you're finding a king or a spade, if you think about this as king or a spade, A is kings. How many kings do we have? We have 4 total. Okay, if we think about how many spades we have 13 spades, but we have a king of spades. So if we added these 2 together, 4 plus 13 is 17, but then there's a king of spades, so we subtract 1, we have actually end up with our 16 possibilities. Okay, so probability of king, another way we could do this, probability of king would be 4 out of 52. The probability of a spade would be 13 out of 52. And then we have to subtract that king of spades, which would be 1 out of 52. And again, we get the same answer. So when you consider this, go back to that basic idea of it's your successes over your total possibilities. Okay, here gives a better visual, I think. A card's randomly selected from a deck of 52 cards. Probability that's a face card or a spade. There are face cards that are spades. Those are represented right here. There's the king, queen, and jack of spades. So we cannot include them in just one of the circles. They're in both. So when we're finding the probability here, the probability of A, which would be that it's a face card. Okay, the probability that it's a face card, there's 3 face cards for each suit, so there's a total of 12 face cards. We have to add that to the probability of it being a spade, which is 13 over 52. And then we have to subtract these pieces that are face cards that are spades. So there's 3 over 52 of those. So doing this math, I get 22 over 52, which is 11 over 26. So another way we could look at this is here's the total outcomes that would make it true. And if you counted here, you would have 22. and then there's 52 total cards. So I think a Venn diagram is an excellent way to organize this information and to really